This movie will just briefly describe the difference between accuracy and precision. These are two words that people seem to use kind of interchangeably. There is a difference between them, and it's good if you understand the difference between them. Accuracy is just how measurements that are close to the true value. So how close are measurements to the true value? So you might have something that we know is 15.0 grams. We know that that's what it is. That's the standard. So when we have other measurements like 14.6 grams or 15.2 grams, we would do a comparison. We calculate what we call a percent error between how far this measurement is compared to what a standard is. So when you're talking about how accurate something is, you're talking about how close it is to a set accepted standard value. Precision, on the other hand, doesn't really have anything to do with what the actual standard is. Precision has everything to do with how well the measurements that you take are related to each other. So if you have like a 14.6 and a 14.7 and a 14.3, these are all very close to each other, and so they are fairly precise. Now the true actual measure of the thing you're measuring might be like 17 grams. So it wouldn't be accurate at all, but it still could be a precise measuring device. And then also, basically, the further out this decimal goes, the more precision we say it has. So I could have a scale that measures to the tenths place like these in grams, and I could have another scale that measures to the 100ths place. So that's maybe 14.62, that's 14.71 maybe, and that's 14.32. And so this gives us another place of precision, we call that. So this is more precise because it goes all the way out to the 100ths place. And in fact, a scale that goes out to the 100ths place can be several $100s more than a scale that goes to the tenths place, because precision really costs money to be able to manufacture. So accurate is how well your measurements compare to a standard value. Precision is how well your measurements compare to each other, regardless of what the standard value might be. Another way to look at this is use a kind of a target analogy. If you look at this first target right here, you'll see that the X's are kind of in all different places. Now clearly that's not precise because they're not close to each other. So it's definitely not precise. Is it accurate? Well, the way you would figure that out is we do repeatability in science, so you take a lot of measurements and then usually you average those measurements to see how close you come to the true accepted value. In this analogy, the true accepted value, of course, is the center of the target right here, right in here. So if I did an average of all these four, you could see that they're fairly scattered around pretty evenly around this target, and if you averaged all four, you'd probably get something right in here. So although they kind of look kind of randomly scattered out here, you would consider this actually to be accurate. Now look at this number 2 target here. Here's all your 4 shots. Well, you'd say, hey, that's pretty some precision marksmanship. They are all right there in a nice little cluster. And that's good, but the bullseye is here. So this is an example of precision. All the measurements compare very well to each other, but it's not accurate. It's not hitting the bullseye. Down here in the 3rd target, you have them kind of all over the place. They're not really close to each other, so it's definitely not precise. The bullets are everywhere. And if you average all of these, you'd probably be somewhere in here, which means you would not be accurate either. So this is not accurate, it's also not precise. So what would precision and accuracy look like? Well, you'd have a nice cluster of shots. They'd all be close to each other. That means it's precise, and they're all in the bullseye. So they are all close to each other, and they all compare nicely to the standard of the bullseye. So this would be accurate and precise. Normally in science, when we're talking about different measurements, like different scales and stuff, we can talk about the precision of a instrument. But normally what we're doing in science is we're talking about how we take measurements and we're going to compare it to something that we know is the true or the known standard or answer. And so whenever we're doing that, we are talking about accuracy. How accurate is the measurements we made? How well does it compare to a certain standard?